Hi everyone, thank you for coming to my demo. My name is Tien, and today I'm very happy to share with you my Insight project. My project is building a tool, ToneAnalyzer, to improve customer service evaluation and satisfaction using speech processing. So why am I interested in customer service? Customer service is a $350 billion industry, and it is a mess. There's a problem I can solve using my data science background. Customer service industry is a very important customer's touchpoint, and businesses want to look good here. However, the current tool for businesses to evaluate their own performance is not 100% perfect. The current tool heavily relies on those kind of text-based surveys that they invite you to complete after your phone call. However, the response rate is not that good. The response rate on average for call centers is actually less than 18%. However, jumping out of the box, I realized that call centers actually own a wealth of data. Each call is recorded. Just that recordings is unstructured data. The current tools is missing out information on things like a person's tone, which is, I think, a very direct form of a person's emotion or satisfaction. Coming from a data science background, I realized that this is where I can add value in by building a ToneAnalyzer to improve the current text-based tool. When I was finding a data set to train my model on, I had an idea. A person's emotion can change during a conversation. So it would be very interesting if I can make a prediction of every sentence around average every 3 seconds. After some research on Google, I find 3 data sets from 3 different sources, which they invite 119 participants to participate with their own accents and ethnic groups. These participants, each of them speak a selection of 47 sentences, and each sentence has to be altered in a number of emotions. Combining the 3 data sets, I have a total of around 8,000 weight files. A little bit about preprocessing. Because my data, there's a little bit variation in terms of length of the clip. I cut them all off at 2.5 seconds to make sure they're of equal length and of equal number of features. The second thing is that since my input data is a signal, so I use signal processing for rate transform to extract interesting features that can be describing a person's pitch, amplitude, frequency, etc. While there are a number of consistent labels across 3 data sets, I pay more attention to 3 labels: positive, negative, and neutral. To solve this ternary classification problem, I first split the data set into training and testing, 80-20, and then I feed all the features into the one-dimensional neural network to automatically learn or select important features and to learn the patterns between the 3 classes. Currently, the accuracy I can achieve right now is 70%, and that is around 40% improvement from random guessing, and that's 30% improvement from a simpler baseline model, logistic regression. With this tool, I can make prediction on every 2.5 seconds or every window. The output of a model can be an emotion trajectory, and I'll be able to take the maximum output of the trajectory to speed out the final output. Now let's do a quick demo of my project here. So here we are at the ToneAnalyzer page. You can choose to upload your file, but for the sake of this demo, I will just hit here and it will submit a sample file to my model. And now it says that the sample file is predicted to be negative. Now let's hear how negative it sounds to you. And let's pay more attention to the tone rather than the context.
Don't forget a jacket.
How does everybody feel about that, that tone? Let me just switch the channel, share the proper screen. Desktop 1. Okay. Back to my slides and presentation. So during our demo, the downcasting tone and also the kind of slower speed was captured by my model, and my model say that's a negative emotion. With this tool, ToneAnalyzer, I will be able to offer a better assessment metrics that look like this. I can have two axes. One axis is the operator. The other axis is the call sorted by time. If I sum over operators, I'll be able to flag important underachieving or overachieving operators. For example, if I sum over operator Baltimore, I'll be able to see that, oh, so this operator is doing a poor job keeping the customers more positive. And if I sort over time, which is the call sorted by time, and I sum over the other axis, I'll be able to maybe understand maybe there's some slot of the day the customer seems to be more neutral or negative. That way I can analyze the customer behavior better. Finally, a little bit about me. My name is Tien. I'm a recent graduate from Harvard Medical School's immunology program, where I use more traditional machine learning to help researchers, physicians to solve their clinical problems. For example, to name one of the projects I worked on, the problem we're solving there is to diagnose breast cancer earlier, so early diagnosis of breast cancer. The data I analyze on is the research data where they recruit both healthy and cancer and non-cancer cohort, and then after they get the serum samples, they run analysis on serum biomarkers concentrations using a unique sensitive protein detection platform in my lab. And the technique I used involves a range of distributed statistics that if I would have to work on early stage proof of concept studies that include a lot of biomarker downsizing. We know a lot of biomarkers can be predictive of cancer's progression or occurrence, but which part of the biomarker, what size of the panel of biomarker is really predictive, and this really we need to focus on. And sometimes as the cohort grows larger, I will be able to make prediction on cancer occurrence, like subtypes, and also treatment responsiveness. Before coming to Harvard, I also had a chance to combine data science and medical device, where I can work on problems like early diagnosis of kidney injury. The data I analyzed on was a combination of EHR and the real-time urine output of my medical device. And in terms of technique, I also use traditional machine learning, distributed statistics, tree-based models to build prediction models to help physicians identify high-risk patients, and that way can prioritize their ward visits. We were very fortunate to be nominated by Forbes on 30 and also competed in Microsoft Imagine Cup. So that's a little bit about the presentation. If you have any questions, I'll be happy to answer them. Thank you.